So my name's Jeff Williams. I am so let's do it this way. So I'm on the national champion 50 and over basketball team. I'm a accomplished boomerang designer and thrower, and I'm also the CTO of Contrast Security. I co-founded a few years back. I've been involved with OWASP for a number of years. I got started really early. I consider myself one of the founders of OWASP. Became the first chair of OWASP, so I was the first global chair of the organization, and I was that for the first 10 years. Wrote the OWASP Top 10, wrote WebGoat, contributed a lot of different projects to OWASP, and I'm super excited to see how OWASP has grown over the years. I'm incredibly excited to talk to you today about instrumentation. The idea of instrumenting software, to me, is just amazing. And I want to try to expose you to the power of what we can do with instrumentation in this talk and get you excited about it. So let's jump into it. I'm going to do a few slides and some demonstrations to show you how you can use instrumentation today. I always try to start out a talk with some facts about AppSec. I don't know, not everybody here does AppSec every day, so I thought it's useful to just set the stage. These are facts that we gathered from our customer base. We've got tens of thousands of real-world applications that we monitor for application vulnerabilities. We look at libraries, we look at attacks in the runtime environment, and we bring all that data together and we publish a report that's got some of this in it. But when you look at these numbers, you should be concerned. Who here banks online? Okay, there's some people that raise their hand and some other liars. There's, because it actually doesn't matter if you use the bank software itself. Your data is already in the same software that other people are using. You're just not using it. These numbers are not fantastic. This says, we've got on average like 30 vulnerabilities per app. Can you imagine if we were building airplanes and every time we did a safety check, we found 30 safety problems? That would be ridiculous. Nobody would fly. But we tolerate it in the software industry for some reason. We've got a lot of open source library problems. That's layers on top of that. You should know, by the way, though, that most open source never gets called. Only 7% of the open source code in an application actually ever runs. And we measure this at runtime. Using instrumentation, we measure this exactly, so we're sure that we've got the right answer here. It's really kind of amazing. The biggest challenge I see with the left side of this page, the vulnerability side, is that, I wrote the first OWASP Top 10 in 2002, and we haven't really changed the game. It's the same vulnerabilities in there today. I thought, we'd write the OWASP Top 10, we'd work on it for a few years, we'd fix some of those things, we'd raise the bar, and we'd issue a new Top 10 with different stuff in it. But it's, we're 19 years later, and it's still the same stuff in there. That's an indictment of AppSec. I love OWASP, I love all the cool things that we've built and done, but we are not changing the game yet. I'm doing a keynote tomorrow morning where I'm going to zoom out and talk about that picture and dig into that problem. But this talk is really much more technical. I also wanted to say we're also under attack. Most organizations don't have good visibility into who's attacking them and how they're being attacked and which systems are being targeted. I just want you to know that it is happening. The average application that we protect are attacked 13,000 times a month. That's a big number. I mean, that's a lot of attacks. So if you combine these two sides of this, we've got a lot of vulnerability and a lot of attackers. It's not a great situation that we're in. So something has to change. But today's talk is about instrumentation. So who can give me an example of some instrumentation? In any kind of thing, not in software, but like in any kind of thing. What's instrumented? Yeah, sure. Like your car's got instrumentation, right? It's got speedometer, it's got tire warnings and out of gas indicators, all kinds of instrumentation, right? You wouldn't drive without that stuff, right? What's some other things that are instrumented? Okay, that's really interesting, right? I don't know if they're actually measuring them directly, but you do get it. I mean, they probably are. But like, I think of instrumentation as being like, directly on anybody wearing a Apple Watch or a Fitbit or something. Guess what? You're instrumented. That thing probably knows you're sick before you do. Instrumentation is key. Like, think about the modern industrial factory. It's instrumented for vibration and fire and temperature and sound and everything that could go wrong. They know when a machine is going to break before it breaks because like the vibration in the factory changed. They would never operate their stuff without instrumentation. It would be crazy because they would never be able to figure out what's going on inside those complex machines. So software is the most complex thing that we have ever created that exists. And it's barely instrumented at all. Log files are terrible instrumentation. If you've ever looked at log files, they don't have the right stuff in them. They don't have, they've got exceptions from errors that get thrown, but log files are like after the fact. They're not real time. You can't decide to turn on some sensors and off sensors. It's really not good. Now, this here is the 9450. This is an instrumented basketball. And I like using basketball examples because I play a little bit. So this thing measures your dribble speed, the arc of your shots, the rotation of the ball, everything, and gives you cool dashboards. And it gives you feedback on how you're playing. In a way, it can replace the coach. And in an industry where we've got a massive shortage of experts in application security and lots of players out there writing code, we could do with some things that help, a force multiplier to help our coaches. Like imagine if you give a bunch of players this ball and they can go improve their skills, get measured by their coach, and their coach can be more strategic, giving them specific things to work on based on the data. That's what we can do with instrumentation. We can empower all the AppSec experts out there to teach their players a lot better. So the good thing about software is that it's really malleable. We can instrument software easily. This is a little diagram that shows how the instrumentation engine in Java works. It's pretty similar in other languages. But you start with the original code on disk. So imagine you've got a binary, some WAR file or a jar file, executable jar file, something. What normally happens is the class loader loads that code straight into memory. And then that's the code that runs, is exactly what was a copy of what was on disk. But the instrumentation API allows you to intercept that process. So as the code moves from disk into memory, you get a chance to insert sensors in it. And you can insert whatever kind of sensors you want to measure what's going on in the application, but you can instrument it as it loads. That allows you to add security sensors to this code so that you can see what's going on inside the application from within. This is exactly the same technique that companies like New Relic and AppDynamics use to do performance measurements. As the code loads, instrument it, they put timing sensors into it. Well, we're going to put security sensors into our code so that we can watch security working and not working. Anyway, so this technique has been around for like 20 years. It's super proven. It's just a little tricky to use. But I want you to imagine doing a pen test with instrumentation. It's almost like having a friend or an agent inside the running application who can tell you what's going on. So, normal test, you're blind, right? Somebody once described pen testing to me as like trying to figure out what's wrong with the water heater by staring up the shower. And it's a little bit like that. You don't have a ton of information coming back, right? So what if you had a buddy inside the water heater who was telling you what was going on as you did your testing? You'd have a lot more visibility. And that's what we can do with instrumentation. Imagine sending a pen test request into like maybe you're using Zap or something. Maybe you send something into an application, and not only do you get the HTTP response, but you get a whole bunch of other information like what route was executed, what configs were accessed, what backend connections got used, maybe show me the SQL queries that got executed during that request. Tons of information, whatever you want. You can get it with instrumentation. So to me, it's critical to moving forward. And I feel really strongly about instrumentation because it tests the runtime reality of an application. It's not testing like the code in a source code repo somewhere that's like, doesn't have the app server and the runtime in it. It's not fully put together. Like, we're testing a real application with real data, real config, real backend connections, so we can get all that context. And context is what leads to accuracy. And as I'll talk about tomorrow, accuracy is critical to getting AppSec right. If you're not accurate, then you have to have experts involved. And if you have experts involved, like me, it's never going to scale. I'm the problem. Dave Lidner here, the problem. So that's a little background on instrumentation. Everybody with me so far? Okay, I'm going to demonstrate instrumentation, but I used to do this with code examples, but it's hard because instrumentation code is a little complex. It's writing code to instrument other code. So it's just it's kind of meta. So I put together a library. This is an open source, free and open source project that anybody can use. You can download it. It's on GitHub. And it allows you to build your own instrumentation agents. Not writing code, but configuring the sensors you want to put in via YAML. So it's a very powerful way to write sensors that anybody can do. And I do think of instrumentation, by the way, like a multimeter kind of thing. Like, you're actually sticking these probes into the methods in your application, and we're going to snapshot information out of those methods and use it to make interesting decisions. So I should say my company, Contrast Security, uses instrumentation in our products. We build IAST and RASP, and we'll talk about those a little bit more. That is a commercial product, and I'm not talking about that here. This is a free and open source library that anybody can use anytime. I just want to be really clear, like, this is not my product or anything. This is a separate thing that I built on the side and made free for everybody because I want everyone to experience the power of observability in doing application security. Okay, so I'm going to demonstrate this rather than, I have slides here, but I think it's more interesting to demonstrate these things. So I have a little application here called Ticketbook. It's got a bunch of interesting vulnerabilities in it and some other things. I'm going to use it with instrumentation. So I downloaded the Jot library. So I've got that here. So you can see I'm in my Jots directory. So you can see I've got my, what in the hell? Hold on. I'm in the wrong place. I'm sorry about this. Okay, much better. So you see I've got my Jot file here. So I'm going to run. I'm going to tell Java to use this Jot file. So I've got I'm going to set an environment variable. This is all you need to do to tell Java to run with an instrumentation agent. Our instrumentation agent is Jot. Okay, so we're running with this Jot 0.9.1. And then I'm going to tell it what Jot file to use. In this case, I'm going to use this USQL, untrusted SQL Jot. And let's take a look at that. Say again? Oh. What did I type? Oh, Jot R, Jesus. Okay, thank you. I was panicking there for a second. So look, this is a ridiculously simple sensor. All we're doing is telling Java, I want to put a simple sensor in these 4 methods. Boy, that's really small, isn't it? these four methods. And you can see I'm excluding this prepared statement. The reason I have to do that is because prepared statement extends statement. And so naturally, Jot will instrument that because it extends one of the methods there. So I'm going to exclude that one because that's safe. But I want to see anytime anybody uses those unprepared statements because they might be insecure. So this is just a simple way of finding these things. And I'm going to capture, the bottom line is the capture. And it says I'm going to capture the args. That's the arguments to that method. You can capture different things with JOTs. You can capture the object, the args, the parameters, and you can, it's actually a Spring expression, so you can call methods on those things to get other data out of the application. So again, like a multimeter, we're going to shove it in, we're going to capture a little bit of data, and we're going to pull that back and use it for something. So now, when I run my application, I just run it normally. And you can see as this application starts up, Jot kicked in. You can see it instrumented certain classes as it starts up. And then we use the application normally. So I can just click on a few pages here and put in some data. And contrast is in the, Jot is in the background watching this stuff. Actually, I'll put LASCON in here so we can see this. So you can see for each of those queries, Jot has logged the actual unsafe query here. You can see it gives me the rule that was violated, the exact line of code, and you can see the full query here. So just imagine that you're doing a pen test and you're trying to find SQL injection. It's really difficult to know what the queries are and everything. So this is really useful information in that context. You can use Jot for anything. It doesn't have to be just for security. You can use it for regular debugging, incident response, like whatever you need to know out of an application. You can quickly throw in a Jot and start gathering that information so that you can see what's going on inside the application. That's the key. That's why this is, it's the Java observability toolkit. It's not the Java security observability toolkit. Everybody understand this simple example? Okay, let's do something a little more interesting. So let's look at encryption algorithms, right? So I've got another Jot here, ciphers.jot. And this is a little more interesting. So this only puts in one sensor that goes into the cipher.getInstance method. We're going to capture the name of the cipher, like DES or triple DES or AES or whatever. And then we're just going to create a report. So the other half of the, Jots have sensors and reports that you can create. So the first one didn't create a report. It just dumped stuff out into log. But you can also save it up over time and create a report. So this will show us where encryption is done in this application everywhere, which is actually pretty interesting because we're looking at the whole app. It's not just the custom code. It's all the libraries, all the frameworks, the app server, and the Java runtime itself. All those things can be doing encryption. So again, all I have to do is just click through these pages to see if any of them do encryption. And I know some of these ones down at the bottom do. So I'm just clicking on these pages. And this is actually, I think, a really important message here is that I don't have to know anything about security in order to do this. All I have to do is just use the application normally. So did I blow it? What did I do? I didn't set my variable. I didn't set my agent. I'm sorry, I'm really having a bad time today. Ciphers. Now I run the application normally. And let me just click on these things quickly and you'll see. Still loading. So when you can use instrumentation to empower regular developers to do security checks, it's a huge advantage because there's way more developers out there than there are security experts. Okay, so here's what this is supposed to look like. So you can see in just a few clicks, I found a ton of uses of all different kinds of encryption algorithms, right? Single DES with different modes, triple DES, AES, password-based encryption, and so on. And if you use this on real-world applications, you'll see encryption all over the place. You can do the same thing with hash algorithms and see, we are never going to be free of MD5 and SHA-1. People can talk about it all they want, but it is everywhere, hundreds of places in the typical Java stack. It's never going away. So again, this is another powerful way of using instrumentation to get interesting security information out of applications. So I'll switch to this slide here real quick, if my screen will. There's like a 5-second delay between when I switch the screen and when it actually slides over. So I just wanted to point this out because this has a few more details on what you can do in a JOT. If you look at the top up here, you can see you can specify the captures in a really powerful way. All of those are Spring expressions, which allow you to take the value that was returned, but if like the first parameter, for instance, if that's a complex object, you can call methods on it, you can call methods on that, and you can extract exactly the piece of information that you want. So like all you do is have to get your probe close, and then you can use methods to expand from there and get the data that you really are looking for. Okay. Now let's do my favorite example. So this one's about access control. So I'm gonna do this first. And then let's take a look at it. So access control is one of the hardest things to test. It was when I was doing a lot of pen testing, it was kind of my specialty, as I would focus in on authorization. And I always found interesting flaws and gaps because nobody tests it. It's really hard. And so, imagine if you're testing an application as like, Joe. Well, you've got a role and a certain set of access to the application. You're viewing it through one lens, but there might be a dozen different lenses to view that application through, and each one might have different access to the app. So when you pen test it from one point of view, you're really only testing that code. We want to test the whole application. So how do we do this? How do we find out what all the access control checks are? Well, we can do it with JOT. I mean, this would take, a lot of time, certainly days, to figure out how to do this on a pen test or a code review. We needed to go faster than that. So with this, I'm going to put in three sensors. The first sensor tells me the route. That's like the attack surface for this application, right? So I want to know the URL that I'm coming in on. The second one tells me the currently logged in user. And you can see, I call on both of these, I call the service method. I'm instrumenting the service method, which is like kind of the main entry point for Java EE applications. And the parameters to the service method are the HTTP request and the HTTP response. The first one's the request. And so when I call P0, that's the HTTP request. And on that, I'm calling get remote user. So I'm like sticking a sensor in and I'm using it to get the information I want. So now I know the route and the user. And the last sensor is the current role, like the role check that I'm checking for. So I want to know anywhere this application does an is user in role check, and I want to know what role they're required to have at that point in the code. Okay, so that all seems a little esoteric. This is not hard to build, right? It takes a few minutes to set up these rules. And then I created a simple report. One is going to be a test coverage matrix, and one's going to be an access control matrix. And I'll show you those because it's more exciting that way. So we're adding by the way, the performance implications of this instrumentation are almost impossible to measure. I've tried. So I'd run like 1 million requests at this and test the total elapsed time and compare the difference. We're putting in some lines of code directly into this application that don't do very much. So this is really, really fast. Okay, so what I'm going to do is just use this application a little bit. I'm going to click around on a few pages here, and we'll take a look at the test coverage matrix here. So just by clicking on a few fields, you can see what I've tested as guessed, right? Now there's a few pages in here that will allow me to change my role. So I can switch to user A and hit a few pages. I can switch to user B here and hit a few pages. And you'll start to see, now I'm building out my test coverage matrix, and I can see exactly what user I've accessed which pages as. Hey, that's pretty cool. Now I know exactly what I've tested and what I haven't tested. That's not something that you typically see in tests. But we also started building this access control matrix. And these access pages at the bottom have this, so I'm just going to click on C, D, and E here. And these pages do access checks. And they look like this. So you can see that page A checks to see if I'm currently in role A. Page B checks for role B. Page C, role C. That all sounds good, but where's page D? It's not there, right? And if I look up in my test coverage matrix, you can see, hey, I actually hit that as user B. So it looks like maybe there's an access control test missing in that page, right? I don't know. The access control is like one of those things some people might call business logic. Like, there's no right answer here. Maybe page A is okay for everybody to access. I would prefer to see it do an access control check for like, guest or anyone or something, but it might be okay. But this is what observability is all about. We're taking something that's hidden inside the application, it's buried in the black box, and we're making it observable from outside the black box. And there's really not much that we can't do this with. You can see also page E has 3 different access control checks in it. That might be fine. Some pages render that way, like they view differently depending on who you're logged in as. That's cool. But this is just a real easy way to expose the access control matrix for an application. Everybody with me? How long did this take me to generate? Maybe if I had a script that just ran quickly through all the URLs on this site, it would have taken me 30 seconds, right? So we can build this stuff really fast. I can take that access control matrix and show it to somebody on the project who should know and say, hey, does this look right? Like, why is this admin page have no access control check on it? And they'll probably say, oh, yikes, yeah, that's a mistake. We need to fix that. We've done this at scale. Like, if you look at APIs this way, you'll find all kinds of APIs that don't have the right checks in them. They don't follow the pattern. And this is a really fast way of finding that stuff. Any questions on what we did here? Okay. So let's do one more thing here, just to give you the full power of instrumentation. I want to show you an expression language injection example. Who here's not familiar with expression language injection? Okay, there's a few people, that's fine. So it's pretty simple. Expression language is a way for developers of taking data out of their application, like some complex object, like a user object or a business object of some sort, and pulling that data out and rendering it in the UI without writing a ton of code. It just gives you a very shorthand notation to grab that data and format it in the way that you want in the UI. So unfortunately, many frameworks, particularly in Java, have gone nuts with this. Like Spring and Struts have expression language everywhere. And so every once in a while, some data flows through the application, gets into an expression, and gets evaluated. Now, normally that's fine. Like if I type in LASCON here, this actually flows through the application. happens to go through an expression evaluation, but it's not an expression, so it just returns the same thing. But if I actually sent in an expression, like 1 + 1, that code gets run in the server, and I get a 2 back, right? So understand, like, that's dangerous. If you're a pen tester or a hacker, your spider sense probably just started tingling because you're like, oh my goodness, you can't let anybody control the code that's running on your server. So then you can start expanding on that concept. You can say like, oh, what if I sent in something like math.max 4,6, 7, whatever. You can see quickly like, oh, hey, I can also call methods. That's pretty scary. And a smart attacker is going to do something, and they're going to say, oh, well, hold on, let me just take over the whole server. I'll put in like runtime.get runtime. .exec, something like open-a calculator. Yeah, it looks right. And so when I submit that, that actually runs a program of my choosing on the server. It happens to be my laptop. It's all running on my laptop here, but normally, they would be running that on your server inside the data center, and they could run whatever they want. Not calculator, they would take over your whole system and do whatever they want, probably uncreatively mining Bitcoin or something. Instead of like stealing your business data, which would probably be worth way more to them. But so that's expression language injection. So what can we do about that with instrumentation? Well, let's look at this, this jot. So this, it has a couple extra things. It has that same routes thing that we looked at before. Don't worry about that. The important sensor here is this one. This instruments 3 methods. The value expression.getValue, that's the actual expression language engine. Like that's what's going to evaluate this. And what we're saying here is if we're inside the scope of a value expression, then we're going to prohibit the use of process builder and socket. You could add other things like creating files and whatever you wanted in there. But you're saying we're creating a sandbox around the value expression method so that you can't just run arbitrary code inside an expression. And the thing that does it is that exception line at the bottom. If we ever see a call that matches this, we're inside the scope and we try to do something prohibited, we're going to throw this exception that says, hey, we detected an attack and we're blocking it with jot. So let's give that a try. So I'm going to change my jot here. By the way, you can combine all these jots together. You can just point it at a directory full of jots and run them all at once. So you don't have to keep switching. It's just easier demo-wise to do it this way. So run my application the normal way, and wait a second for it to deploy. And let's try that same example again. I'm going to cut and paste this. I can't type it. So you'll notice the app still works just fine, right? We can even evaluate harmless expressions because we're not doing the prohibited things. But if I try to enter that malicious expression and do a runtime.exec inside there, then jot will stop it. And you can see I got a sensor exception. We blocked it. You can even see in the stack trace here, if you drill down a little ways, you can see here's our value expression. And inside that scope, as you read up the stack trace, you can see inside there, we tried to call a runtime.exec. Okay? Or process builder is actually what we banned, which is underneath the hood of runtime.exec. Everybody with me? Okay. So 5-second count while I switch back to my slides. Okay, there we go. Okay, so I'm going to publish these slides so you can have them if you're interested. I did want to show these. I just added this to Jot. Is you can add sensors to an application, and it's a little bit like putting cameras up in a bank, right? Like you just put a camera in the right places, and then every time somebody goes through the bank, you can get a little chart of their progress. So like this shows one thread of execution through the software. And I can put whatever sensors I want here, right? This one I just kind of threw the kitchen sink at it. I said, give me everything. I know you can't read that because I can't even read it from here. So that's a bad sign. But trust me when I say this goes through and says, the top call is basically a get parameter call. And it says, hey, I just got like the name parameter. And then like going down a little ways, you'll see another call that says like runtime.exec or SQL statement.execute or an expression language evaluation or whatever. And like, it doesn't have any smarts to it. This isn't trying to detect vulnerabilities or anything. This is just creating observability. Okay, but with this, you can easily see like, oh, like that first one is a SQL injection, the second one's expression language injection, the third one's command injection. And by the way, under the hood in command inject, anytime you call runtime.exec, Java creates a whole ton of ciphers, like all of them, which is just kind of weird. But that's the kind of thing that you start to use instrumentation, you'll see weird stuff inside your applications that you didn't know was happening. Socket connections out to the internet that you didn't know were happening, like phone home stuff, all kinds of things that you just didn't know. Now this idea I think is really powerful. Most security vulnerabilities are reported to developers through PDF reports. This is not the ideal way of communicating with developers. I just want to check my time here. It's a little better if, 300-page PDF report is not the right way. I want to ban PDFs from security forever, by the way. It's a little better if your results are in a dashboard somewhere. That's better. Even maybe better if they get into a Jira ticket and get reported that way. But still, there's a lot of extra steps there for developers. What if we could communicate with developers the way that they want to be communicated with? Like right through a failed test. Well, imagine we just, we use that expression language thing or, another jot. We could easily fail a test case. If that test case, when it runs, it causes a runtime.exec to happen, you could throw an exception and fail that test case and report it right to the developer, right through their test run. Like this will show up in their IDE naturally. You don't need a separate security vendor's IDE integration to do something. This is just naturally going to fail the test case and give them the results that they want. They will fix this right away because their test failed and they won't check it in until the test passed. So I think this is a really powerful way of communicating with developers. I wrote a whole article about this on LinkedIn if you're interested to talk about the pros and cons of this. But I want you to think about how security can do a better job of working with developers. This is just one way. We did this example of expression language injection already. And so I want to zoom out a little bit. What we just did is called IAST and RASP. So IAST stands for Interactive Application Security Testing. That's a Gartner name. That doesn't really mean a whole lot. What it really means is that you found a vulnerability using instrumentation. That's it. That's what IAST is, using instrumentation to find vulnerabilities. And it's got a lot of advantages over things like static analysis and dynamic analysis. Interactive analysis works from within the application. It has a bunch more context than those other tools, right? It sees that whole real world app reality, the runtime reality I talked about before. So it's much more accurate at finding vulnerabilities because it only can report what it actually observed, observability, right? And we just built our own IASTs, right? We detected some vulnerabilities using instrumentation. You can build your own IAST with Jot. There are products on the market that have a bunch of more complicated built-in rules. Contrast is one, but this concept is available to everyone right now. RASP is pretty similar from a technology point of view, but RASP, which is runtime application self-protection, this is using instrumentation to detect attacks. And it's weird in our industry that forever, The vulnerability people have been totally separate from the attack people. But really, attacks and vulnerabilities are pretty similar under the hood, right? I think of it like, vulnerability is like an open window in your house. And the attack is somebody climbing through the window and stealing your stuff. It's all about the open window. But the technologies are very different. How do we detect attacks today if you're not using RASP? Say again? They have to try to actually attack you, which is true of RASP as well. But the way we detect them is at the network perimeter, right, with a WAF. And why is it noisy? Because a WAF has no idea what it's protecting. WAFs overblock and underblock, and it's never going to fix that because they don't have enough information. The information they need is inside the app. WAF doesn't know if that parameter coming in is a comment that's not harmful, or something that's going to go right into a query that goes to your database. But with RASP, we can protect it at the right place where we have all the context to say, hey, that's definitely an attack. You can even, if you used a more complicated JOT, you could analyze the whole query and say, hey, the attacker's data just changed the meaning of the query. That's what we're going to block. So these technologies, IAST and RASP, are really exciting. They're in pretty wide use in big companies, but I still think there's a lot of people that haven't really experienced them. The shift that we're looking at here is moving from this outside-in model where we're using scanning and we're using firewalls to a model that works from inside the running application. And it's an observability approach. It's directly measuring the running app, so it's more accurate. When it's more accurate, we can get rid of some of the experts like me out of the CI/CD pipeline where we can't be. It's a real-time technology. So these JOTs that we just wrote, they were working right as we were working. That's really important because you can't have a scan that takes 3 hours to run inside of a CI/CD pipeline that has to finish in 15 minutes. That's just math. So there's a number of advantages to this. You can put this instrumentation out there. It can just run in the background. Developers don't even need to know it's there until it detects something. So in a lot of ways, it's like guardrails that will just make sure that nothing goes out of bounds. No extra steps. And ultimately, this technology will allow us to build pipelines that do all the security checks that we need. Like whatever you want to check, you can check it with JOT. You can check it with IAST. And you can build a pipeline that's really strong. You can add tests for whatever whatever your security controls are. You can add tests for that. Build a strong pipeline that'll allow you to push code into production at whatever velocity you want to go. That's a real carrot that you, as a security person, you can take to the development teams and say, hey, let's go this direction. Let's work together to build this pipeline so that it's strong enough so that I'm sure that it's safe enough to go into production. And you're happy because it can go as fast as you want to go. That's freedom. So ultimately, I think that's the key to DevSecOps, is to changing the work from what we do today, which, and I'll talk more about this tomorrow in my keynote, but the work of AppSec today it's kind of all over the place, to work that focuses on this, to allowing teams to push code into production at super high velocity with security. And the results that what we've seen are spectacular. If you look at the blue line here, the red line here, that's what static analysis produces. So that says, this is a mean time to remediate chart. So how long does it take you on average to fix vulnerabilities? And if you look at the red line, this is the median to close a vulnerability is 121 days. It's like 4 months. That's a really long time and a huge window of opportunity for the attackers. If you look at the blue line there, that's what IAST can produce. You get much faster feedback. In fact, if you wanted to look for a definition of shifting left, and again, I'm going to talk about that tomorrow. Shift left is, you see shift left, is not the be-all, end-all solution, but if you wanted to get more efficient closing of vulnerabilities, this is a chart that shows that. And for our best IaaS users, the one that have been using it for a while, you can see the numbers get really good. 75% of vulnerabilities closed in just 8 days. That's a real difference. Something really changes in your company when you can do that. So that I'm just gonna, that's the end of my remarks. I want to point you to a couple articles. If you're new and getting started in application security, I'd love for you to read this article on how to vulnerability. I spent 15 years doing consulting, finding vulnerabilities, writing up findings, and I got a lot of experience in doing that. So this is a tutorial on how to write up a great finding to make sure that you communicate effectively and don't burn down any bridges. The second one is a broader article about the future of AppSec. And it talks about how do we build security in a software factory. So it's actually repurposing the machinery of a software development organization in order to also produce security. So it's a little different view on kind of the traditional approach to AppSec, but I encourage you to read it if you're in the field. So with that, I'll stop. And I'd love to hear any questions. I think we've got a few minutes left. So if anybody has any questions about anything related to AppSec, I'd love to try to field them. It's Stump the Chump time. Yeah?
Hey, can you talk about merging APIs and AppSec so that you can basically have one single agent to do your stress testing, your pen testing?
Yeah. So the question is about merging application performance management, like tools like New Relic and AppDynamics and Datadog and things like that, with instrumentation-based AppSec tools like Contrast and others. And in principle, it's a reasonable idea because then you only have to add one agent to an application to measure it. Really, you can run two agents side by side. They don't affect each other because it's like, one's putting in one kind of camera and the other is putting in another kind of camera, and they don't really conflict with each other. So we run side by side with New Relic and AppDynamics and all those. But I do think that the future is likely that you'll just use one agent and get all of that. I'll say that just in terms of the market, like in terms of vendor company-wise, there's plenty of work for a security company to do to focus on like instrumenting for security, and there's plenty of work for a performance company to focus on instrumenting for performance. And there's not a lot of synergy between those two activities other than the fact that they use the same underlying technology. So I don't know if it'll happen, actually. It might happen, it might not, I don't know. Yeah.
Somebody wanted to know where you stored it. But the question was, what is your definition of a vulnerability?
Yeah, so I mean, if code demonstrates a problem that's, like one of the OWASP top 10 or one of the things in ASVS, like it violates one of the things that we expect it to do, I'd call that a vulnerability. Some of them are critical, some of them are not. I tend to focus only on the critical and high stuff because most people don't get through that. And it seems foolish to me to focus on the mediums and lows and stuff before you do the highs and criticals. Yeah. There is a weird distribution of vulnerabilities, by the way. Like some apps have a ton of vulnerabilities, and some have very few. So the distribution is not like that flat. Question?
You're talking about open source and 7% how that actually executed.
Yeah.
For supply chain, obviously these tools are exploding. One of the frustrating things about them is they're really good at saying this library has a CVE.
Yeah.
Go fix it. Well, am I actually executing that code or not? How can instrumentation help with that?
Yeah, it's a fantastic question. Now, Jot doesn't. Well, you could put sensors in Jot, but it's not designed to solve that problem. But Contrast, for instance, we use instrumentation to measure not only exactly what libraries are there in the real assembled running application, which is like the first thing, you gotta get the right libraries. And if you're just looking at the source code repo, you got a bunch of libraries that don't ever run, like test libraries and stuff, and you're missing a bunch of libraries that are in the app server and the platform and things, really important libraries, but you don't see them in the source code repo. But if you're scanning the actual application, you see all the actual libraries that are there. And so that's the first part. The second part is we measure exactly what methods are used in each of those libraries. And that's where we get this data, is when you actually measure it, only 7% of all that code. So here's how I break it down. The whole application is 100% of the code. Slice off 20%, that's your custom code. And then of the remaining 80, 74% is unused open source, and 6% is used open source. And I say 6, I said 7 before. It's 6 if you're looking at the code for the whole application. It's 7 if you're only looking at what percentage of the open source code, of the 80% used. That's why that number sounds like that. But I consider most of the findings that come out of some of the other vendors' tools false alarms, because in many cases, no code in those libraries runs. I think it's more than 50% of the libraries never run at all. They're just a transitive dependency that's required. So if you've got library A at the top, and it brings in B, C, and D brings in E, F, and G, if you never use a feature in B, you're never going to see any of the code in E, F, and G run. So there's tons of those, and if you report vulnerabilities and that stuff, you're reporting false positives. That's not dangerous. And to your question earlier, it's not a vulnerability if it can't be exploited. So that's why it's a key capability to be able to know what open source code actually runs. But open source software supply chain stuff, really important. One quick note on that software supply chain topic, because it's really important in the Biden cybersecurity executive order and NIST initiatives and so on. I think of 4 things when I think of the supply chain. I think of first the code you write. And even though it's your organization writing that code, it's really part of the supply chain. It feeds into the final product, right? The second piece is code that you import. That's your open source libraries. Certainly really important piece. Third thing is code you run. That's like your SaaS, the APIs you're using, products that you bring in. It's another whole bunch of code that feeds into your supply chain. And then the last thing, and this is really under-focused on, but SolarWinds just shone a bright light on it. It's the code that you write with. And that code is really important. It's all the stuff that you use to build your product. And if one of your developers gets hacked, the attacker's got a 4-lane highway straight into your executable that goes either into your production or your customer's production environments and really hurts people. That's exactly what happened in SolarWinds, and it can happen to everybody. Everybody is SolarWinds. Sorry, your development environments are not locked down. Their developers are downloading tools off the internet. They're running libraries. I don't know if you've ever watched a Maven build anytime recently, but it downloads the whole world before it starts running. So, just be careful. I think you should start putting initiatives in place to lock down your development environments so that attackers can't use that as a pathway into your production. Any other questions? We got 3 or 4 minutes left. Yeah.
Speaking off that last statement, isolation, there's also isolation.
So when you say developer isolation, do you mean keeping them out of production environments?
They're the developer
Yeah. Yeah. Sounds like an interest. I'd love to talk to you a little bit more about that. But remember, if developers are writing code, it doesn't matter, I think of it like east-west developer communication doesn't matter that much. if they're downloading stuff from the internet onto their machine and running it there, and their machine gets compromised, then the attackers can use that to commit code into your pipeline, and now your product is compromised. And then when your product goes into either your production or customers' production environments, it's compromised, and they can use it to launch, attacks from there. Not really. It's really early. I mean, somebody's going to make a startup and make $1 billion. I don't know. I'm already busy. I'm just dropping ideas, just laying them out there, just millions of them. Yeah, okay. Any thoughts on instrumentation? Anybody want to try it? Who's going to go take a look at Jot? I know not everybody's a developer, but anybody want to give it a shot? Okay, I see some very quick hands. People go. That'll be awesome. Let me know how it goes, and if somebody wants to build the .NET Observability Toolkit or the Ruby Observability Toolkit, it's not really a tremendous amount of code, so it'd be awesome. I'd love to work with you on that. Okay, thanks everybody. I appreciate it. Please do stop by our Contrast booth and say hi to my friends David and Adam here and the folks in the booth. It'd be fantastic. Thanks.